Hello and welcome back to Fullerton College's Print 101. This is Professor Ben Hewitt, and we are still talking about ink. So, we're now going to talk a little bit about some problems. A lot of issues that happen, especially in offset printing, are all caused by an imbalance between the ink and the water. Remember that the water or the fountain or the dampening is what controls where the ink can go. So most of the problems happen when the proper tension between the two things is not maintained. When one of them gets the upper hand and pushes it, then you have problems. If there's too much water, then you don't get any print. And if there's too much ink, the whole page gets covered. Many issues are caused by some imbalance between the two. So one of the biggest issues is something when ink and water do mix, because while oil and water don't readily mix, it's not impossible to combine oil and water. Many of you have probably in the last year of pandemic experimented with some home cooking, I should hope. I've actually developed some delicious sauces now. I make a very good panini. Thank you very much. But you might notice that in some sauces you make, like a good pesto sauce, for instance, I know it's a bit 90s, but it's one of my favorites. You have to eventually combine water and some sort of fat, whether you're using an olive oil or a butter or some other oil, but I wouldn't recommend anything else. They don't taste as good. But those things actually combine when you apply enough heat and you apply some other ingredients, maybe an acid. A lot of times you will be adding a little bit of lemon juice to break it down and make it combine better if you want to combine oil and water during a cooking process. All this is to say and to establish, A, I'm hungry, and B, it's possible. And a printing press has a lot of energy being put in. There's a lot of pressure and therefore a lot of heat. As we already talked about, the distributor rollers warm up the ink and work it until it has energy in it. And adding energy is one of the things that can break down the oil-water barrier. Not saying that it directly causes it, but it does mean that it is possible to get a point where the fountain solution and the ink combine into one emulsified, not so tasty pasta sauce. And when that happens, you no longer have any control over the ink, because once the ink and the water are friends, then the whole thing gets covered with a tint, which is to say a very, very diluted ink. It can happen. There's also something called scumming, which is where a part of the plate that's not supposed to take ink starts to take ink. This is a picture of one of the precautions against things like scumming, which is to make sure that the ink doesn't dry too soon. Make sure that there's no oxygen reaching the ink before it gets pumped directly from a container into the press. This is if it's really a concern. Anyways, that's one of the ways you can stop it. So there's also a lot of specialized inks that are beyond the normal things. Normally, colors are process colors. Inks are process colors. They're cyan, magenta, yellow, and black. And they're also, if you're using a one color press, a cheaper black that doesn't need to be quite as neutral as process black. Now, there are special inks that are used for special things, such as, but not limited to, vegetable oil-based inks, because these are less toxic and less harmful in the environment to create. Reducing the need to mine for petrochemicals, you can argue about the effects on the environment of farming, but typically speaking, soybean growers are not damaging things quite as much as the people who are blasting holes in the earth to pull out the last bits of oil. So vegetable oil works pretty well. It also means it's not as bad to throw it away and compost it later, get it back into the soil. Also, it's a safer thing to work with. By having vegetable oil based instead of petrochemical based, the solvents necessary are less of a problem. They also do some other things. Vegetable oil inks are actually becoming very popular. It turns out they can give you a purer, more neutral oil, which means that the inks can be more pure and more neutral, meaning you can print a wider variety of colors and they come out sharper and brighter. Now, the only thing is they don't dry quite as fast or as hard as more conventional polymer inks, but that's getting better. Well, yeah, we'll see if that's true. Conventional inks may become more environmentally safe, which will make vegetable inks less desirable. But the other thing that the book did not take into account is that vegetable inks are also getting better. Moving on. So there's a bunch of different types of inks here. We'll take a look at some of these, I believe. Yep, we'll go through all these quickly. Sheet-fed inks have a lot of vegetable oil, commonly linseed. Yes, linseed oil is a vegetable oil. Linseed comes from the flax plant. As you know, you can eat flax if you're eating health food stuff. It's also what makes linen, as in linen shirts, linen pants, and bed linens if you're getting actual linen bed linens. I like linen as a fabric. It's good stuff. Anyways, they contain less petroleum distillates, and they're good for up to 8 color perfecting machines, which means that you can print them on both sides at the same time. Remember, perfecting press has no impression cylinder, but rather a second set of blanket and plate cylinders and all the other rollers and inks below. So you print both sides of the sheet at one time for a faster print. If you're doing that, you need ink that's going to cure pretty quickly, because you're going to have a lot of set-off problems if you stack something that's been printed on both sides. Imagine putting peanut butter on both sides of a bread and then stacking it with other bread with peanut butter on both sides. What's going to happen to that stack? Also, I guess I'm still hungry. Sorry about the food analogies. Hopefully you guys have snacked or just had a meal before you listen to this. Electrostatic printing. This is one of those things where you go really far and wide out of your way not to say the word Xerox. But anyways, Xerox type inks, which are really toners. These are not inks so much as they are dry plastic particles. They are attracted to the paper by static charging the paper using a laser to ionize the surface, and also oppositely charge the particles so they stick like static cling. The same reason your socks stick to your shirts in the dryer is the same reason it sticks to the paper initially. But if you've ever unjammed an electrostatic printer, you know that can wipe right back off if it didn't go through the fuser. And what does the fuser do? The fuser heats the paper up to just below the burning point, and by applying pressure. This stuff has to resist a lot of stuff like evaporation if it's a more liquid version, which does exist. And it also has to soften enough to be able to transfer. So, laser proofings. Hexachrome. Hexachrome's an interesting thing. Hexachrome specifically did not catch on as much as we thought it was going to. So hexachrome was a way of, it was a Pantone, if you guys have heard of Pantone color. If not, we'll talk about it, don't you worry. But hexachrome was developed by Pantone as an alternate form of process color. Those of you familiar with color management a little will already know this, so you can nod along with me and feel superior. But anyone else, I'll bring you up to speed. You don't even have to worry about not knowing, because here it comes. So cyan, magenta, yellow, and black do not have the capability to mix any color. They have the ability to approximate most colors. There are some serious gaps in the gamut. It has difficulties printing purples and blues, and has difficulties printing lighter colors and very intense greens. One of the workarounds developed by Pantone was hexachrome, and I can't remember the exact tones of color used, but it used a 6-color primary. Instead of cyan, magenta, yellow, it was 6 primaries and black to print it. And that gave it a much more chance to hit wider gamuts. Sorry, I got all distracted. That happens sometimes. But this didn't really catch on, and one of the biggest issues was there's not enough software support for this type of separation out there. What did end up catching on, and this is big on offset as well as some more advanced digital presses, is a 6 or 7 color printing setup called CMYK OGB or OGV. So you have your CMYK, cyan, magenta, yellow, black inks, which print most colors that we're used to seeing in photos and stuff. But adding 2 or 3 extra colors to that, realizing that you don't need to reinvent the whole wheel to build a wagon, you just need a second wheel, right? So they just added a few extra colors to compensate for the parts that aren't doing so well. So it's hard to print purple. Great, let's add violet as an ink color. Now you can hit all those purples and those rich blues that you couldn't hit before. It's hard to hit greens that are very bright. So great, we'll add a green ink. Sometimes they'll even add an orange ink. That's what orange ink. And orange, grink is green and ink in one word, grink. Maybe I'll copyright it and patent it. Buy grink. But anyways, orange, green, and violet. Those colors take up the parts of the gamut that are much harder to print. Sometimes you use 1, 2, or 3 of those, and that lets you print a much wider gamut. Hexachrome TM didn't quite make it, but the CMYK OGV does fill that role. And it's really cool stuff, and I hope I get to use it more in the future. Proofing inks. Anyways, ink proofs is a way to try and produce a proof, a single copy that you're going to show somebody before you print the final project. So these are ways, these are set up in a way that will be able to be washed a lot off. They compensate for the porosity on proofing press rollers. Proofing press sometimes will take a plate and print just once. This is not something that's done all that commonly anymore. Most proofing now is done either by a very, very color controlled inkjet or an electrostatic printer. Unless you have a ton of money, then you get an ablative donor sheet proofer, which I've never seen in the wild, but desperately would like to play with because they sound exciting and expensive. Metallic inks. They are what they sound like. They have metallic powders, like aluminum or bronze, ground up into a powder and put into it. Think like glitter, but much more fine. If you've ever used craft paints, they have metallic craft paints. There are metallic markers out there. It's the same sort of thing. It has bits of metal in it to let you print a metallic look. Now you can do it without heavy metals. Somebody say excellent air guitar for me right now. Thank you. Thank you, you in the back. Good job. Okay, good. But anyways, it used to have to use heavy metals. And heavy metals, if you get into them, are like rare earth metals, and they're not good for humans to touch, and they're really not good for us to eat. You really don't want a whole lot of metal in your diet. Save a bit of iron, really. Magnesium is not terrible for you, and zinc isn't bad for you. But the bigger the number, the bigger the atomic number, it seems to be that the worse that metal is for the human biological creature. So we want to stay away from those. So things like food and toy packaging. Toy packaging? Yeah, and if you have kids, they put everything in their dang mouth. Sorry. Anyways, so water-based metallic inks also give a good brilliance, and they've been developed for multicolor presses. It's a thing. Now, metallic ink doesn't want to be used instead of one of your 4 colors of process. It wants to be used in addition to. Some big printing companies now also have a system where they will print a silver, or basically just aluminum, but a silver color, because aluminum and silver look kind of similar in ink colors. But basically a silvery aluminum finish that's one color, and then they'll print normal or even Pantone transparent colors on top to tint that to give you your colors. So if you want to print a gold, you could buy gold ink, or you could run a metallic base color and then drop the right amount of yellow, depending on what kind of gold you want to get, on top of that to produce that. UV curable inks. This means you're going to use an ultraviolet light to make them hard. It means they're a liquid polymer that turns dry and turns solid when hit with a UV light. My first experience with this sort of thing was a dental thing when I was a kid, because they used to do these, I don't know if they still do them, they'll do sealants. They'll like put a plastic coating on some of your teeth. And I really hope this doesn't give me any sort of diseases when I'm older, now that I'm saying that out loud. And then they cure them on to make them hard and polymerized using a UV light. And that protected your teeth from decay and stuff, supposedly. Anyways, so polymerization, it takes the plastics that are liquid in the ink and converts them into plastics that are solid on the paper. This is also popular in inkjet now, and it allows you to print on a variety of substrates that are otherwise unprintable. If you want to print on foam board, cardboard, plastic, wood, glass, outhouse, farmhouse, wait, no, wrong movie. But if you want to print on literally anything, glass, you want to print on glass, that's great. Use UV inks, you can print on glass. You're not going to get glass through an offset press, because what happens if you put glass through something with 60 pounds of pressure per square inch? Have fun cleaning that. But contactless and what you calls them? Wow, brain fart. Sorry, guys. Inkjets can do that. And it's fantastic. It's near miraculous to watch happen. When we're in person again, I will demonstrate my UV ink press, because it is delightful. Waterless inks. Ha ha ha. Remember, that's the punchline of the semester. Waterless printing, guys. It's the future. Certainly not Xerox and electrostatics or HP and their patented semi-liquid, semi-solid digital press indigo thing. No, no, no. It's definitely an offset press with slightly different ink. Remember, the waterless printing is like normal offset printing, except instead of including a fountain solution, you instead have to have a special climate-controlled booth because you're using chemical resistance on the plate itself, as opposed to dampening to control where the ink goes. We'll end on the joke of waterless printing, and we'll come back for more in another video. Thanks for listening. I know this is a bit of a long chapter, but we're printers. Ink is kind of important to us.